Um, so that we have this. So carbon likes to make four bonds. So carbon can make four bonds in a couple of different ways. One way that it can do it is this. I'll just draw some example molecules. Okay. So that shows each one of those lines shows a sharing of two electrons. So in that case, carbon has kind of eight electrons around it, four that it brought itself in its form of its valence electrons, and then four that it's kind of sharing from each of those four hydrogens. That shows that carbon has four things surrounding it. Whenever carbon has four things surrounding it, it is hybridized as something known as sp3. It is sp3 hybridized. Now, what does that have to do with? Well, that has to do with where each one of these atoms is has those electrons. So hydrogen's valence electrons are in the s orbital. Carbon's valence electrons are in the s orbital and the p orbital. Now, what I think is the most direct and fastest way to answer this sort of question is to look at the things that are surrounding that central atom. And most of your questions regarding this are going to be about, well, what is the hybridization of this? So if we saw this right here, carbon has two hydrogens. It needs to share basically two more. So that right there, that's a formula of H. Let me write the formulas out. CH4, H2CO. Now the hybridization of this, the way that I always think about hybridization is I add up the number of things that are around my central atom. So in these cases, carbon is my central atom. And I will almost always do this. I add up the things by counting in this fashion. S, P, P, P. So CH4 is sp3 hybridized. It has four things surrounding it. So I added up S, P, P, P. Now, that next molecule, H2CO, how's that hybridized? Play along with me at home. S, P, P. How many things are surrounding that central carbon? Three. So, what do you think the hybridization of that carbon is? Feel free to add to the sp2. Perfect. So this is sp2 hybridized. Now let's go with this right here. And just so you guys are if you're curious, chances are whenever I give you a question about hybridization, I'm going to show you the molecule. So that's going to be helpful. What do you think the hybridization of this molecule, also known as CO2, is? Done. How many things are around my carbon? sp. I have two things, two oxygens. So sp is what surrounds my oxygen. So this is sp hybridized. Now, since we're talking about organic molecules, this is kind of the extent that we're going to. Now, if you looked at some of the answer options, and I'm going to switch colors here because I'm going to erase this, um, can this get much more complicated? Yeah, anything can. Well, what would that look like? And play along with me at home. SF6. This is just kind of the next level. So don't think about, oh man, we're going to see this on the exam. But let's think. This molecule looks like this. Yeah. F, F, F. It's 4, 5, and 6. And let me erase my SF6 there. How many things surround that sulfur? We got 6 things around there. Stanley, I like where you're going. You're absolutely right. Okay. Now, this is one of the places where it gets tricky. We have 3 what are known as p orbitals. So we count up, just as you did, S, P, P, P. But then after, so we get, let me write this sequence out, 1 s orbital, 3 p's, and then we go on to d's. And there's, let's see, I think that it's 5. Yeah, it's 5. And then 7f. Okay. So what you do for this is you count up S, P, P, P. Now I've used all my P subshells. Where do I go after that? D, and then D. So what do you think the hybridization of SF6 is? Perfect, Caitlin. Awesome. Joint close. You forgot the 3 after the P. But yes, yeah. You hit the important money part about there's 2 D subshells that are used. So it'd be sp3d2. But that's if you have 6 things surrounding your central atom. And we're not going to have 6 things surrounding our central atom. We're really most interested in organic molecules because we're talking about organic chemistry. Pretty much. So we only need to know the 3 or 4 from for carbon that we talked about. Yeah. And so I'm happy that we're having this conversation because let me erase all of this right here. Now, let's think for just a moment about, well, how can this stuff, how can you kind of like take different things and wind them up together? Let me give you an example question. A carbon in octane will have what hybridization? Okay, let's dissect that. A carbon, okay, so we're asking about carbon and hybridization, but I'm giving you a little bit of an example molecule. Octane. What do we know about octane? OCTANE. Well, the ANE, what does that tell us about our molecule? ANE means nothing but, oh, that's ENE, octene. ANE means we've got nothing but single bonds. So ANE, okay. What about the OCT? We've got 8 carbons. Okay, so we've got 8 carbons and a bunch of single bonds. Now, it might be helpful to try to visualize that molecule or try to draw it out. 1, 2, 3, 4, 5, 6, 7, and 8. I got a bunch of hydrogens on here. I'll pause right here. Um, what's the hybridization of this carbon that I've just highlighted? I'm going to complete the molecule. You go ahead and add to the chat what you think the hybridization of that highlighted carbon is. How many things is it bound to? Sorry, I didn't. I think. Okay, so we've got. Sorry, this carbon that I've highlighted, I need to. My drawing isn't very good. I apologize, guys. So that carbon goes to a hydrogen, another hydrogen, three hydrogens. Then it also has a carbon-carbon bond. So now I'm going to switch it and I'm going to highlight the things that this carbon is bound to. It's bound to this, this. So that's two things, three things, and then down to this whole chain. Caitlin, great observation. Yeah, absolutely. So it's a part of a chain. So it's a part of this longer, bigger molecule. Does that make sense, folks? So, okay, what we're going to do is we're just going to say that this hydrogen is one thing, this is one thing, this is one thing, and then this is one whole thing. So this carbon, how many, go through and ask yourself a couple of questions. How many bonds does that carbon have? Four bonds. Would everyone agree with me on that? Throw a yeah or a thumbs up or something in the chat. Okay. You got four bonds. We've got, I'm going to go ahead and itemize them out. One is a carbon-carbon bond. And then we got three CH bonds. So this is four bonds, four things. So since it has four things, it's SPPP. So it's sp3 hybridized. Does that make sense, folks? Okay. Now, I'm going to try a different functional group. And if you guys have to go hang around though, if you want, by all means. Now I'm going to switch it up. So that was a carbon in octane. Now what I'm going to do, if it, Stanley, that's a great question. What you have to keep in mind though is what are the functional groups? So here what I'm going to do is I'm going to change my molecule. It's not going to be octane anymore. I think that the name would be octanoic acid. Now, for this specific molecule, octanoic acid, I would show you that structure. And I would point to a carbon and say, what's the hybridization of this? That's the way that I would ask this sort of question. Or I would use, the name octanoic acid. How many carbons does that have? In which case, I'd want you to use the prefix oct. Okay, it's got 8. So to answer your question of 1 to 10, all have sp3, as long as they are not rings and they have the ane suffix. Because let's look at this right here. This is octanoic acid. So this functional group right here is a carboxyl group or a carboxylic acid, or this molecule is an carboxylic acid, that group, yes, Caitlin, absolutely right. Now, let me erase all of this. And I'm going to take this molecule and give you what I think is a question that you guys can answer, and I might give you on an exam. What is the hybridization of the indicated carbon? Okay. So I'll give you the structure, but I haven't asked the question yet. I will put a box around the carbon that I'm interested in you guys telling me about. In which case, what I'd want you to do is I want you to look at this carbon and say, okay, there's a single bond. So that's a bond going to one thing. Here's another single bond. That's another bond. So I'm going to keep a running tally. We got one bond going to one thing, another bond going to another thing. So this is one, this is two. And then I'm going to get my highlighter and I'm going to go after this. That is my third thing. It is a double bond. But when we talk about hybridization, we're not so much interested in is it a single, double, or triple bond as how many things is it bound to. So when we talk about things, my tally here is up to 3. So add to the chat, what would the hybridization of this right here be? Keeping that same sort of sequence. S is one thing. P is a second thing. P is a third thing. sp2. You guys got it. That's exactly right. So, be kind of careful with yourself, be patient with yourself, and you guys got it. So that's the sort of way that you could see a question like that, where I would narrow it down and I'd say, like, this is the molecule that I'm talking about, and this is the specific carbon that I'm talking about. I like this sort of question because it's giving you maybe a little bit of a different perspective on the molecules that you've seen before, and then applying uh, tools that you have. And then if I were to, yeah, yeah. So that's kind of what I'm thinking. All right. Does anyone have any other questions? I'm not sure if you have the time, but could you also go over counting number of carbons and methyl groups and how we know if it's 1,2-diethyl, whatever. Sorry, I don't get. Okay. Okay. So let's see. So if we did that, let's take a look. Let me go ahead and get a new slide. Okay, so and Stanley, drug info from first class. I'll get to that in just a second. All right, so let's go ahead and I'm going to give you a chain. Let's go with C, 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 C. And then I'll do this right here, C. And let's just imagine that all of these carbons they have all the necessary hydrogens that they need, just for the sake of time. So if we had something like this, let's go with that. Yeah, there you go. That right there. Okay. Now, what we want to do anytime we're looking at a molecule is we want to figure out what is the longest possible chain that we can see. So if I start right here, I'm starting on the left-hand side, and I'm going straight line left to right. How many carbons is that? L2R, 5 carbons. Okay. So in that case, we're looking at pent. Now, oh, great. I can switch my highlighter color. Okay, so that's going to be boom. Now I'm going to go with green. I'm going to start down here. Okay, so how many carbons is that? 1, 2, 3, 4, 5. 5 carbons. So we're talking about pent. Okay. Now I'm going to switch my highlighter to orange. Okay. And now I'm going to start up here. Oh, what on earth is that? Okay. Start up here and go from there down. Okay. So I just went with orange. I started on the right-hand side and I went down. That's 1, 2, 3, 4, 5. 5 carbons. Still pent. Um, I think that whenever you guys look at this molecule, the longest possible chain that you can put together is 5 carbons. And so if I were to just kind of continue on, um, I would keep coming up with 5 carbons. Would everyone agree with that? Okay, cool. So what I'm going to do is I'm going to erase all of my highlightings. We agree that this is pent. We got a pent prefix. Now, a fair question for this is, well, what do we do with that? Because you can see that there are a total of 7 carbons. So why is this not pentane? Why is this not 5 carbon ANE? Well, the reason for, or sorry, why isn't this heptane? Sorry, because it has 7 carbons. Why pentane? And the reason for that is this group right here, and I'm just kind of arbitrary, like I'm just randomly selecting these. I'm going to select that group and that group. Those are branches, is what we commonly refer to them as. Those are kind of branch points from this. So would everyone agree that this is 5 carbons plus 2 branches? And each branch is, how would you describe that branch? Or what's the term that you would use to describe that branch? Maybe meth? Methyl. Perfect. Awesome. Caitlin, you took that extra step. I was stopping with meth just because there we go. But it's a methyl. Okay. And I mean, there's 2 branches, so they're both methyl. So since we have 2 branches, would you agree that we've got dimethyl? And then as soon as we've taken into account those two, I'm going to go ahead and say, there's my main chain of 5 carbons, dimethyl pentane. Does that sound like a good name for this? We have methyl because those are our each branch is 1 carbon. We've got di because there's 2. And you could count any of those branch C's to be yes. Now, Caitlin, that is a fantastic question because now we've got to take it kind of one more step because I want to throw this molecule at you. Um, C, 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 C. There's my pentane. C, C. Now let's kind of we'll go through this molecule a little bit faster. There's our pentane. You agree with that? And then the other part was one methyl group, another methyl group. So would you agree that this name is dimethylpentane also? Okay. I appreciate your hesitancy. because that means you're like, I understand this, and that no, that yes, but no. Um, this molecule that I've drawn is also dimethylpentane. But you look at these two, and I think it's pretty reasonable for you to say, I have taken chemistry long enough that as soon as you make the smallest change to something, it's a completely different molecule. Therefore, these molecules can't have the same name because I know chemistry has rules and they love rules in chemistry. The same reason why a seven carbon molecule is somehow not a heptane. Would you agree with that? These are different molecules. And so the way that we indicate that these are different is, yes, you're right, is we have to give these methyl groups that I'm going to circle right here, and I'm going to circle right here, we have to say where they are. And so what we want to do is I'm going to give you two different options. I'm going to start with the molecule on the right. Um, I'm going to call it 2,3 dimethylpentane or 3,4 dimethylpentane. Now, between those two, do you think one of them is right and one of them is, maybe it's a little dramatic, but one of them is wrong? Caitlin, you're absolutely correct. This one is the correct name for this molecule because when we number those methyl groups, we want to give them the lowest possible numbers. So that's 2,3 dimethylpentane. If you looked at it and you said, oh, 3,4, well, that's kind of an answer that are you off the island altogether? No, you're not. But that's not the best answer. 2,3 dimethylpentane is the more accurate answer. What does that mean? Does that mean that we start from here numbering one, two, three, four, five? Does that mean your rule is, oh, we always start from the left? No, it isn't. Our rule is that we give our functional or give our groups, our branches, our functional groups, the lowest possible number. That's what we aim to do. So that's why 3, 4 is a less right answer. Now, with respect to our other molecule, this is kind of a tricky one because if we start on the right hand side, 1, 2, 3, 4, 5, or if we start on the left hand side, I'm going to switch my color here. Ooh, 1, 2, 3, 4, 5. This is either, well, let's 2, 4 dimethylpentane. If we start from the left-hand side, or if we start on the right-hand side, it is, oh, 2,4 dimethylpentane. Either way, we're giving it 2 and 4. Does that help? Thanks. Thanks. I was pretty pumped about it. Um, when I was a kid, there were these things called Lisa Frank. I remember all the girls in my first grade class had them. It was like folders with unicorns and cats. Anyway, I feel like I'm channeling Lisa Frank to be a chemist there. Okay. Um, Stanley, drug info from the first class. What is your question with respect to drug info from the first class? Will that be on the test? Yeah. There will be questions regarding kind of the different definitions, like what's a drug target? Um, those sorts of questions will be on there. And then the process, the drug selection process. I know we've kind of moved away from that stuff because we kind of got into chemistry quite a bit more, but it's still going to be on there. So the drug design process. So if we look at, let's see, I'm jumping back to the PowerPoint, um, or the I'm going to open up the PDF, I think. Yeah. The PDF had some questions or it had some kind of descriptions. Jump ahead a little bit. Okay, so if I share, I'm going to share this slide right here. So the overall process of drug development. So the sequence, discovery and development, preclinical research, clinical development, FDA review, and post-market monitoring. Those are the steps of the process that I'm talking about. So I might have a question that's like, the pharmaceutical company and FDA continue monitoring the safe and effectiveness of this drug. Um, what is this known as? Or this is which step in the drug development process is this? Is this best describing sort of thing? Oh, sorry. Yes, post-market. So I'd have like, all of these different options, discovery and development, preclinical, clinical, FDA review, and post-market monitoring. Yeah, so those would all be on there as options. And then you'd select, well, you're kind of use the clue as like the pharmaceutical company and the FDA. So those two have kind of approved this drug and they're going to monitor how safe and how effective it is. The FDA alone would be basically, when the FDA is working alone, that's when the FDA is reviewing something. Awesome. Awesome. I'm happy to hear that, Caitlin. I'm going to go ahead and stop my recording, Stanley.